So here we are on Friday, sexta-feira, making a live stream on HTTPS, and that will be for SSL and TLS, secure socket layer, socket layer and transport layer secure. And what does it mean? Last stream that we made on this series was that we create basic authentication when the client access to the site, and then it was request the username and the password, so the user logged in to that site. So you were working on HTTP. HTTP is a clear text, so anyone was that could listen to the wire, to the communication, could get the username and the passwords of the user that logged in into the system. So some years ago it appears a protocol, first of all the secure socket layer, that using the one private key and one public key that are symmetrical, and creates a better way of securing this communication. How is this protocol, or how does this protocol works? Well, first of all, the HTTP for the standard HTTPS works on port 443, and it's normal that you'll find out that when you are logged in to a place that is working on HTTPS, you'll find out that you have a key, a green key, or perhaps not, saying that the information is encrypted. So how is this done? First, you have to create a private key, and that private key, and from that private key you will create a public key or certificate key, and when the client begins the communication to the server will send this public key back to the client, and after, the client will begin to use, will begin to send the information, but encrypted. This information, let me change the color, will be right now encrypted with this public key. The information arrives to the server can decrypt the information using its private key, and then it sends back the information again, also, but using its private key. And therefore, the information stays. Properties. Let me change here the color. Well, let's put another color here. Not here. Here. Where is the color? So the server will send the information encrypted with this private key. And so what happens if another client appears? The server will then send not the same private key, but the certificate that is sent to the client. It's also a certificate that was originate first of all from the private key, but you can't, even if you get both certificates, those public keys, you can't find out, you can't get to the private key. Why not? This is a mathematic algorithm that when you produce the private key and you remove the certificate or the public key, it's not possible to find out what was the private key in the beginning. So what we're going to do right now, we're going to create SSL TLS communication, and first we're going to create this private key and also the certificate, and then we'll create the virtual host, and after we're going to access from this client to this server using the HTTPS protocol. So we have already the two computers, and first of all let's create private key. To create private key, let's get in, and to create private key, what we have to do is you should create it and as root, or probably as root. Here on the home folder of the root, it's the best place, at least there won't be not many people to get in there. You can create here the private key and also the public key, and then move it to their destination folders that we shall see. So to create the private key, this is what we're going to do. So we're going to create private key. After we are going to extract a cipher from that private key, cipher from private key. The third step will be extract the public key and signed with the cipher, and the fourth will be since when you create a private key and the public key, each time you are going to work with the private key, you will need to put the password. We are going to remove the password from the private key, and fifth step will be place the keys public and private on their folders to be used by Apache or any other software that might be used. Okay, so this will be the steps that we're going to do. So first one, let's create the private key. We are already in the root home folder, and we begin to use and we will use the OpenSSL. This is open software that you can use to create private and public keys, and then it's free and also secure. So you'll use OpenSSL, that you generate dash, this will be the description, and out will have the private key. Since we are going to create also something that I didn't explain before, we are going to create a site. This is this is the main objective, is to create a site, a secure site, secure in means of communication, secure site that will be secure HTTP .local, for instance. We're going to create this virtual host and this site. So when you are creating the private key, you should at least give the information for which site it will be used, but it can be used on any other site, on any that you might want. So we'll say that this will be for secure HTTP, okay, dot local dot key. Well, the name of the key could be what you want. Just we are just saying that it will be used on that site. So then you will create the key, and you say how many bits the key will have. So it will have 4096 bits. It will be a bigger key. And right now is asking to, so you can place here the password. This password is the password that we'll use each time that you need to use this key. So alias -il. Right now you can check that here is the key. You can also look at the key. Cat secure key. Okay, so this is the RSA private key using dash with encryptation, and this is all you have. So let me copy the comments to your document. So we create the key. After we create the key, now we are going to do the second part. We're going to extract a cipher that will be used to sign the public key. So after we do this, now we're going to extract. So we'll use the same Open SSL using the protocol X509 rec. You're going to sign also and say for how many days this key is signed or is valid. This is we have to say the validation of the key. So this key will be valid for 1 year, 2 years. Say a number. For what? 4 days? 4 days only? Okay, let's make 400. 4 days might be too short. Then you say that you'll get in OpenSSL. Oh, sorry. This is rec. Sorry. Request. We are requesting. Sorry. Request a new key from this key, and right now we're going to have the same key, but generally we say it's CSR cipher. Okay, so from this key we are going to create a cipher. So look, each time we are using the private key, it asks for the password. So you have to put the password. Now, this cipher, you have to put the country. So perhaps PT. Then the province. We are in Lisbon. And default city, Lisbon also. And default company. What name of your school? As this, yeah? No. So ZS Z this EZSE this. Okay, school. Right? And organization unit, Erasmus, and server name or the host name. This is important for what we are doing for training purpose. It doesn't matter, but the name should be resolved by DNS at the outside, since the password is probably sometimes to be used on the one the host name or the server name should be or should have DNS resolution outside. Okay, so you can have your, I don't know, each time what was the name of our server, remember? Let me check. Host name. Oh, you don't have a name to our server. Just let's give a name to our server also. Password. And our server, it will be called, what's the name of our server? Host name CTL set host name. Give me a name for host name of this server. Name, please. Name. Give me a name. What? Okay, pastel, right? And the domain will be nata. Sorry, pastel. Okay, and you can also accomplish saying what's the IP of our server? IP address. We're working 10.200, right? So you can say echo 192.168.10.200 for pastel nat.local.pastel, and we'll say send this to etc hosts. And right now you can check doing host name -f. This is the full qualified domain name, and with D you've got the domain, and with A you've got alias. That is the host name generally of the server. So I'm going to put it here. This is before we extract. So here we're going to give fkdn. You know what's fkdn? Full domain name, full qualified domain name. Qualified domain name, okay? And the full qualified domain name is, he has a host name, and then he has a domain. This is how it's done. Ours is, our host name in this case is pastel, and our domain will be nata.local. Okay. So let's get in. You won't see here because in this session the variables from the host name and fkdn they aren't available. But if you close this terminal and if you open a new terminal right now, you can check that you are at server pastel. Okay. Even if you log in as root, right now you are on pastel. So the host name will be what was the name? Pastel nat.local. So generally this fkdn, this full qualified domain name, is the name that has a DNS resolution in the one. Okay. Now he asks for the email address. The email address is the person that is responsible for the security or for the certificates or for the passage of the private and the public key. So email address could be someone at email.local. Okay. Then it asks for a challenge password. In this case, it's not necessary to give the challenge password. And right now, I'm going to copy this information to your document. So this is the private key. Uh, 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 this is wrong. So this is what you have to do. Let me make some changing here, because okay. So Pastel, it's our server. After we create the Pastel, you can look and see that right now you've got the private key and the cipher that was extract from the secure key. So from the private keys. If you cat HTTP cipher, right now you see that is a certificate request that we create, and this is the beginning. They mathematical. They are connected and related using generally the I don't remember the name right now. With numbers. Oh, okay. No. It's Friday. It's difficult for me. Now, right now, we have to do the third step. The third step is that we have to sign. I'm going to extract a public key from the private key and sign it from private key and sign it with the cipher key. So this will be the third step. Okay. And the command that we have to do is open SSL, always using this, and now using the protocol X509, and then we say rec, and now you're going to say the days that it will be signed for 100 days. You said that week in you'll got the cipher key // CSR, and you'll got the sign key will be .key, and out we're going to have a certificate that will be sent to the user. Oh, it's missing something here. Days. Rec. This is days. Okay. And now it's okay. So look, once again, since we are using the private key, it needs the password, and so we put the password. After now you have three keys: the private key, the cipher, and the certificate or the public key that will be sent to the client, to the user. If you check what's the inside secure key.crt, you'll find out that's a certificate here. Okay, and this is already signed. But each time we use this private key, it was necessary to insert the password. And since we are now making the system and we have to connect this private key and this cipher key, this certificate key to a virtual host, each time you restart the service or the server, someone will be needed to enter the password, and that's not a good method. At least it will give some jobs to many people, but we have to do this more automatically. So from this private key, we are going to remove the need of insert the password, and for therefore each time we make a reference to this key, you don't need to put the password. So right now we are removing remove the password from the private key. So what we're going to do, we're going to make here a swap in passwords. So right now we'll do open SSL, and using the RSA algorithm, you say that in you've got double HTTP key, okay, and from there you're going to remove key, but you'll say that's without pass, okay. Once again, since we are using the secure HTTP, the secure key, it was needed the password. Right now he'll have 4 files. This file, look inside in terms of size, is almost like the same size of this one. It now each time that we are using this key, we don't need to put the password. So now we have to make a swap of the keys. So one swap private keys, for instance, and we'll make a copy minus or even you can make a move, for instance, move minus v, and say secure key. So this is the private key, and we'll say with the key, and we'll say that with password, okay. And right now we're going to move without password to secure key. So we are making a swap. This key was the key without password. Right now we're renaming to secure local key, and before we took the key with the password and say that we moved to another name, saying that right now it has the key. So if you look once again, let me copy here. Now if you check about the size, now you'll see that this one, it's the private key, but as the lower size, and this was the original key with the password. If you can go inside, oops, you can go inside here, you can see the difference in terms of bytes. So after, what you have to do is we have to put these private keys in the folders that Apache will use. Now if you go to ls etc, and here you'll have on pickup I, here you've got here many information. This is certify authority who gives the keys, that from which then will provide the public key. But you've got here TLS, okay, and inside TLS, transport layer secure, you'll find this another folder for certificates and another one for private. So we're going to put here the private key and here the certificates. Let's check what's inside. Certificates, inserts. You've got here two links. These certificate keys are or were already made to some service that we have here on the system. So let's copy. We'll copy -va just to check what is the status of the copy, and we say this is HTTP. Secure. You're going to copy the key to etc. pick up y TLS, and then we're going to copy to private. Okay, and we're going to copy the cipher key, the certificate key, sorry, for certs. Okay, right, then you can check right now. Can use now you can check where is it? You can check that right now you've got secure local inserts, and on private you'll have HTTP secure local key. So you've copied them to that port. Now this is the secure part. Before we go on, now we're going to the second step, or the sixth, that will be create a virtual host that will use SSL TLS. To do so, you need to install another module. That is why also Apache it's well known as a module and a module daemon. So if you have to install, to do so, you have to make yum -y. I think that we don't have here rpm query list SSL. I think it's SSL. Oh, what's the name of the model? SSL mod SSL. I think mod SSL. No, it's not installed. So you have to install it first. Yum -y install. Check first if you have connection to the one. No, we don't have no connection to the one, so we have to do if up np0s3 and if down np0s8. We have to change this name. If down, and now let's ping. Yeah, so yum -y install mod SSL. Let me check. Yeah, I think before it's being installing, let me see if we can show you that in this particular look, before it's installing the model, this is the content of our folder, the confd, where we have our virtual hosts. Okay, after, well, someone is tapping on the wireless cable because the connection is not too fast. But anyhow, so since we don't have that model, after we install it, we'll find out that we'll have here another another virtual host, or at least a file with that ends in .conf. It's ssl.conf. Let me check. So install the software. Let me say also here, put this note. You might need to install another module. It's mod SSL. So this is the command that you have to do. Install mod SSL. Okay. So after installing, and I'm going to if down, I'm going to np0s3 and if up 8, just because you have two connections. Okay. This means about routing issues and other stuff. So it's better if you have only one interface for now on. So we have installed it, and if you come here to the terminal, I'm going to make the same command again, and right now you check that he's installed this module. This is SSL module that allows us. I'm going to restart the service, or before that, if I come here and say HTTPS at localhost, okay, you don't have no connection because it's not working on. So but after we restart systemctl restart HTTPD, when right now if you do press F5 for update, you'll find out that right now SSL is just working, and we've got here an issue because this yellow strip, or this information reporting some errors, it means that it doesn't know this certificate. If you can check the certificate, and this certificate was created for some organization. It is not a certificate that we have created, but this certificate was a certificate that SSL has already created. The problem is it's not signed for certified authority, since VeriSign or others, and the browser doesn't know the stamp when the key is signed for those certified authorities. What it means is that it has a stamp, the key has a stamp of the certified authority that gives us a secure information that at least that key is secure, or it was produced. Jesus, it was produced by certified authority. So we say add exception, Jesus, and right now you are on the localhost but working with HTTPS. So now, since we are going to create the model, we can use. Let's go cd httpd.conf.d, and here so we can use this virtual host as a module to make our modifications. So we're going to copy this ssl.conf, copy minus verbose, and for all attributes ssl.conf to what was the name of the site? It was secure, something like secure httpd.local. Okay, so and .conf. So we'll use the SSL file as a module, and we copy it and then we can open this secure and make the modifications that we want for our site. Here, set number, check the line numbers. Here is where the port that is listening. Normally, HTTPS is listening on port 443. Okay. Now there is a lot of comments here and a lot of information that you might enable or disable by comment or uncomment these lines. This is the cache. You don't need to use it, and here you start up the random with 250 bits, and the crypto is also used. This is the default virtual host. You can change it and say that it will be for any IP address, and here is the document root. Document root right now will be on secure HTTPS. Is this the site, right? What's the name of the site that we gave us? HTTP, yeah. So it will be secure http.local. This will be the document root. The server name here will be secure http.local. That will be the port, and the error log will also be secure http.local, and the access log also secure http.local. Warning level, it's okay. All the protocols it will be used, and you need also here, what is missing is here are the parts that you need also to change. So now the SSL certificate file, this is the certificate that will be sent to the user. You have to change it, and look, it's already on the folder that to where we copy the file. So you have only to change here and say this will be secure http CRT. I think that was the name that we have created. Right, where is it? Yeah, now local. This is the name, local. Yes, full name of the site. So .local, and the private key will be on private. So oops, sorry. Secure http.local.key. Okay, so this will be the two lines that we need to change, and here you can say it was what would be the certify authority, the type, kinds of ciphers, but you don't need to do anything else, and MIME types and virtual host, and that's it. You've got here SSL engine on, and okay, you don't need to change anything else besides this. Yep. Yeah. Okay, so I'm going to copy the file, and I'm going to put it inside the document. Just give me a second. And this is the final content of the file. Let me check something. Echo doc. Whoop, we don't have it. Doc equal home student, and this is Paul what? Paul May Okay, this is it. So grep -v -v. I don't want no comments inside of it, and secure. Yep. Okay, so we'll send right now to $doc, and here we have, oops, a few lines here. Now this is our virtual host. Now what we need to do is to create a document root in 6.1. So create document root. What else? Document root inform or place URL in etc. hosts, and document root index also HTML, and that's enough. So make dir var, our document root was //secure http.local, right? Then echo something inside. We'll say it is my website is working on HTTPS. Okay, and finish one, and we'll say this will be for var //secure index .html, and echo 192. Today it's, what's the date today? 18th, right? 18/5. Let's be the first site. Secure http.local, and we'll send to etc. hosts also. And okay, after we do this, any suggestions that something that we didn't do and we have to? You need to do anything besides this is the configuration for Apache, but what about the system? Do we need to do anything else? Now, right now, if you make net start -intp grep HTTP, you find out that HTTP is listing on port 80, default HTTP port, and on port 443. That's okay because we are working with HTTPS, and it is also listing on that port for a site that we made last training class. Now, do we need to do anything else? Do you need to open anything? Firewall. So firewall needs to be open. Firewall -c, let's list ports, and firewall cmd add port, it could be HTTPS, say 443 on TCP, make it permanent, and then reload the firewall with the new configuration. And let's check what's the ports that right now list ports that the firewall right now has open. So permanent. Ha! I don't know how to write permanent. Okay, so right now it opens the port and now is listening on port 443. Oh, not listening, but is expecting that someone will arrive on port 443. Now, there is also an issue, and the Secure Linux, as you can check, will now have some problem. That is, we need to inform that to the Secure Linux that this key that we have provided has some errors. So here, 6.2 open firewall port 443, and 6.3 we need also to inform Linux of the usage of a new key, private and public, as you can check. So I'm going to restart the system, the HTTPD. So systemctl restart HTTPD, and you'll find out, I think, that you've got an error. And look, you've got also new SEL Linux secure alert. So show, and here you find out is the comment that you need to say to the SEL Linux that right now you are using a new key that he doesn't know, and he knows that the HTTP will be using this key, but he didn't know. So you have to inform him, copy, paste, and right now you just add this. I'm going to close again this information. I'm going to restart again, and you've got here another error, and this now will be for the public key. Okay, copy, paste, and right now is working for this key. Okay, this was the comment that was used to inform SEL Linux of the new private key. And here for public key. Okay. Now it seems that everything is working. Let's close this. Let's restart again the service. And it failed, but must be another issue, perhaps a VirtualBox issue. Let's check what it is. Journal CTL control XEA, and this says it can't find make socket. VirtualHost has no effect. We remove the next time. I'll use the make socket on port conf line, the fifth line on basic authentication. We've got here a problem. And what else? Said it can't find this process. So there's something that you should also do is you should move ssl.conf, since he's listening on the same port, to ssl.conf dot original, and you may keep it. It's not a. You may keep it. And right now you have the same virtual host from the original SSL virtual host. And we might use it in another day. This is secure the original ssl.conf virtual host. Okay. Now let's restart again the systemctl, restart httpd, and right now is working. So the problem was we had two virtual hosts listing on the same port, but using the same port. So right now let me check what will happen if we press F5 here. Now we'll find out HTTPS on the localhost. Right now we have a different key, view, and this is the key that we have created. Look, organization use it, and Erasmo. This is the canonical name, the full canonical name, and when it was created, and valid before, after. Look, not before. It has year 18th, and it will finish if 400 days after, will be in 22 of June next year. So add exception, sorry, and get confirm security exception. Right now we are looking at my site. Just let's go to our client. Here's our client. Windows 10 is somewhere. Here it is. Let me check where is connected. Internet. Oh, this is from the last class where we capture. May keep this. And let's add here another site, another entrance on the hosts, on Windows hosts. This is what secure HTTP, right? And let's save it. And right now, if you press HTTPS secure http.local, then you say be advised the information is not secure. We say advanced, add information. You can see the certificate. This is the certificate that was sent from the server to our client. The public confirm, and right now we are working. This key is also good as other ones. The only problem that is it's not signed by no certify authority, and therefore, and the browsers, they don't have the cipher in, so that could allow them to get in. So I finish here the film and live stream, and today's Friday and it's hot, and probably we need